Venkateshpudi. At the outset, I would like to show my gratitude towards the iapt members and committee for giving me this opportunity to participate in this esteemed competition. This is Dr. Venkateshpudi, Department of Physics, NBK Science and Arts College, Vidyanagar. My educational qualifications. I did my PhD at Sri Venkateshwara University, Tirupati during the year 2008. And I did the PGDCA in 2010 conducted by Yoshakti Educational Society. This is a government aided program. Along with my students, I completed this course in 2009 after my PhD. And I did my MSc in Sri Venkateshwara University in 1996-97 and BSc in the same university in 1993-95, intermediate, Board of Intermediate Education in 91-92, and SSC 10th class by the Board of Secondary Education in 1990. Co-curricular activities. My co-curricular activities are project. I acted as a project supervisor for intermediate public examinations, environmental education in 2011. Acted as a deputy warden for boys hostels in 2011. Acted as a judge for science fair in Vidyanagar, the local school 2015. Now I am acting as a coordinator for Red Ribbon Club in 2016. Extracurricular activities. I am the reviewer for American Association for Science and Technology and reviewer for Journal Physics Science Research International, PSRI, the member in National Geographic Society and a member in Trust for Human Welfare, Nellore. And my professional qualifications are, I have 3 international publications which are published in reputed journals and 4 national conference proceedings. Among them, 1 national conference was published in an international journal, that is IEEE. And I attended 6 national conferences and 2 international conferences, 1 workshop and 2 national workshops, and 2 seminars, 2 orientation programs, 3 refresher courses, 1 symposium, and 2 academy educational programs conducted by Bangalore, and 1 invited lecture. And these are my brief introduction about my educational qualifications and my biodata. Now my topic is Introduction to Nanotechnology. In BSc 3rd year, the nanotechnology was newly introduced. The topics, these 9 topics were taken from this well-known book Introduction to Nanotechnology by Charles P. Poole, Frank J. Owens. The chapters are nanoparticles, metal nanoclusters, semiconducting nanoparticles, carbon clusters, carbon nanotubes, quantum nanostructures, nanodots, nanowires, quantum bells. These 9 chapters are newly introduced in 3rd year BSc recently in Andhra Pradesh. So objectives of the talk: nanomaterials, what are nanomaterials, and types of nanomaterials, synthesis of nanomaterials, properties of these nanomaterials, and the applications of the nanomaterials. These are the objectives that I am going to discuss about you in this small class. First of all, I would like to introduce what is a nanoparticle. Nanoparticles are generally the combination of atoms but the size of these atoms, clusters, are in nano size. The less than 100 nanometer is basically preferred as nanostructural materials. The table shows the classification between bulk, nano and molecules. Bulk material, the number of atoms should be greater than 10 power 6. For nano, the number of atoms 10 power 100 to 10 power 5 atoms, and molecule 1 to 10 atoms. The size is, the bulk is greater than 100. If the size is 1 to 100 nanometers, it's nano range, and if it is less than 1 nanometer, it comes under molecule. So nanoparticle is nothing but a cluster of atoms. The size is in between bulk and molecules. Hence, these nanomaterials are commonly known as nanoparticles, artificial atoms or quantum dots. Why these are artificial atoms? They are not general atoms, but it follows the quantum mechanics. That's why it is called quantum dots. In atom, the Bohr model in atom, these are the energy levels: 1s2, 2s2, 2p6, 3s2, 3p6. These are the energy levels in atom. Similarly, in nano quantum dot or artificial atom, in nanoparticles, Jellium model says that there are some energy levels. The energy levels are known as 1s2, 1p6, 1d10, 2s2 and 1f14. And this is the basic difference between bulk, nano and molecules. So nanomaterial, nanoparticle is a cluster of molecules, a cluster of atoms. A Greek word nanos, which means dwarf. 1 nanometer is thus 1 billionth of meter or 1 millionth of millimeter. It can be expressed at 10 power minus 9 and abridged as nm. How small are nanoscale particles? These are the different sizes in the nanoparticle range. The atoms are in this range, whereas a nanoparticle is here. Hemoglobin is the larger particle size of nanoparticle. Poliovirus is still larger, and so on. The types of nanomaterials. Nanomaterials are basically 3 types: quantum wells, 1D, one-dimensional nano; quantum wires, 2-dimensional nano; quantum dots, 3-dimensional nano. If the bulk becomes well, well becomes wire, wire becomes dot, dot is 3-dimensionally nano-sized, wire is 2-dimensionally nano-sized, where well is 1-dimensionally nano-sized, bulk is a bulk material. It is not nanomaterial. As per preparation of this method, preparation techniques are concerned, nanomaterials can be prepared in so many ways. Among them, in which reproducibility occurs, they are listed here: bottom up and top down, ball milling, laser sputtering, RF plasma, chemical methods, cell methods, pulsar methods. These are the commonly used worthy preparation techniques to prepare nanoparticles. Bottom up. Generally, in this method, nanodots are prepared. Nanodots means 3-dimensionally nanoparticles. These are prepared by these methods. So bottom up and top down, 2 methods are there, and atoms are combined together and they make into clusters of atoms. The cluster of atom is in the nanoparticle size. This is basically in chemical method. It occurs in the chemical process. This is the bottom up process. In top down process, there is a lithography where the bulk material is subdivided into nanoparticles. Ball milling. The bulk material is poured into the grinder It grinds into the nano-sized particles. This is generally known as ball milling methods. It's a mechanical methods. Generally metals are prepared, metal nanoparticles are prepared in this method. Laser sputtering method. Atoms ejected from the metal plate due to laser bombardment. In this method, laser beam is impinged on the material. Helium metal disc, laser beam is focused on the metal disc, then helium was pumped into that chamber, then nanoparticles are generated through this orifice. The size of the nanoparticle is the size of the orifice in the method. RF plasma method. Metal heated due to radio frequency. The rod which is in the RF coils is collected the nanoparticles. Helium was evacuated, so this evacuated chamber, helium was pumped into that. Helium should be in the plasma state. In that plasma state means in the atomic state. So these chemical methods. In chemical methods, more reproducible ಇದೆ. This simple chemical is decomposed in the presence of toluene at 105 degrees for 2 hours. Aluminum nanoparticles are prepared. These small aluminum nanoparticles can be extracted by using titanium isopropionate as catalyst. A Sol-Gel method. In this method, no high temperatures are needed. It is cost effective and very easy to prepare nano-sized particles. In this method, the precursor material is a